in this example of arithmetic sequences and series, we're going to have a little bit of a change in terminology. And up to this point, we've been talking about sequences. Now we're going to talk about what a series is. In series, really nothing changes other than we're looking at a finite group of numbers with a series versus if we were talking about a sequence would go on infinitely, and we would indicate that, with the ... That means it continues on. But we're going to look at where we're wanting to find a sum, and a sum means to add them up, and we have a specific number of terms that we want to add up. So therefore, we're going to change our terminology a little bit. We're going to talk about series because it is a finite set of the sequence. Finite means that we can list every one of them. Infinite means that it goes on and on and on, and we can't really list them all because it goes on infinitely. And for the help, or to help us with this, we're going to use this sum formula to be able to do this. So we're given S of 15. We want to find the sum of the first 15 terms of this sequence or series. We're going to find this series of this sequence, the sum of this series. So first of all, we're going to use this formula up here. S of 15 is going to be equal to, in this case, n is going to be 15 times my first term, a sub 1, plus my 15th term, a sub 15, divided by 2. All right? So again, we're going to have to do this in steps because most of this information I already know, but there's still one little piece that I don't know. I know how many terms I'm going to do. I know what my first term is, a sub 1, it's going to be 25. But notice I'm only given 1, 2, 3, 4 of the terms, and I've got to have the 15th term. So I've got to start out with this thing, and I've got to find the 15th term. But before I can do that, I'm going to have to find the common difference. So I'm going to do this in steps, as I said. So the first step, step 1, is going to be find the common difference. And we know that we're going to have a common difference because it's already been told to us and defined as an arithmetic series. And we know if it's arithmetic, it's going to have a common difference. So to find the common difference, D is going to be equal to, remember I go to the second term and subtract off the first term. So if I do that, then the common difference, D, is going to be a negative 13. So I know the common difference. Okay, so I got that part done. Now let's go to the second step, step 2. I want to find a sub 15, the 15th term of this series. So to do that, I go back to my general rule. A sub n is equal to a sub 1 plus n minus 1 times my common difference, D. All right, I already know what a sub 1 was by looking at what was given. A sub 1 was going to be 25. We just found the common difference up here. So D is going to equal negative 13. And of course, we know n is going to be what term we wanted to find? We're going to find the 15th term. So n is going to be equal to 15. All right, so now let's use substitution and put in all the things that we know. So if we do that, we know that we're finding the 15th term, a sub 15, is equal to the first term, a sub 1, which was 25, plus, remember, n is whatever that subscript is, so it's going to be 15 minus 1 times my common difference, which is a negative 13, and I'm going to put that in parentheses because I have a negative number there. So that's going to be equal to 25 plus 15 minus 1 is going to be 14 times a negative 13. All right, so I'm going to come over here to the side and I'm going to multiply these out. If you have a calculator there, you can use your calculator if you'd like. Well, I know the answer is going to be 25, and I know this is going to be negative because I have a positive times negative is going to give me a negative. So now let's multiply 14 times 13. 3 times 4 is going to give me 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. A 0 for a placeholder. 1 times 4 is 4. 1 times 1 is 1. Then we add. 2 plus 0 is 2. 4 plus 4 is 8. And bring down the 1. So it's going to be 182. 25 minus 182. Then we got to take the difference between 182 and 25. So let's do that over here. 182, subtract off 25. And yes, I know that the 182 is negative, but still the signs are opposite, so I have to take the difference. And I know the answer is going to be negative because the bigger absolute value number here is 182. So, can't subtract 5 from 2, so I have to borrow from the 8, make that a 7. That's 12. 12 minus 5 is going to give me 7. 7 minus 2 is going to give me 5. Bring down the 1. So it's going to give me a negative 157. So I know that a sub 15 equals negative 157. Now, I might want to do a little bit of a check at this point and go back and look at my original sequence. And that does seem reasonable considering that after the second term, everything tends to be going negative from there. And my 15th term, I got a negative number, so that kind of tracks. So that's just a little bit of a check for me to be able to see where I'm at. Okay, so I'm good there. So now I'm ready to find the sum. So step 3, find the sum of the first 15 terms. Remember, our formula was going to be 15, or n, times my first term, a sub 1, plus my 15th term, a sub 15, divided by 2. That was this equation that we had to begin with up here. All right, now let's go down and let's simplify that and substitute and work that out. So it's going to give me 15 times my first term, remember, was 25, so it's going to be 25. And my 15th term was negative 157, and that was divided by 2. So now let's go ahead and simplify that. So I've got to take the difference between 25 and 157. So 157, subtract off 25. And that's going to give me, let's see, 7 minus 5 is going to give me 2. 5 minus 2 is going to give me 3, 132. So that's going to be equal to 15 times 132 divided by 2. That's going to be equal to 15 times 132 divided by 2. Let's do a little bit of long division to do that. So 2 will go into 13 6 times. 2 times 6 is 12. 13 minus 12 is 1. Bring down to 2. 2 will go into 12 6 times. 2 times 6 is 12, so it comes out even. So that's good. So that's going to give us 15 times 66. And then to find the answer to that, we'll come over here to the side. We'll multiply that out. Again, you could use a calculator if you got a calculator. So 66 times 15. 6 times 5 is 30. Carry the 3. 5 times 6 is 30 plus 3 is 33. 0 for a placeholder. 1 times 6 is 6. 1 times 6 is 6. So that's going to give me 0. 6 and 3 is 9. 6 and 3 is 9. So that tells me the sum of the first 15 terms of this sequence, which is called the series. The 15 terms of the series, their sum is equal to 990.